Hey guys, welcome back to another video on Reagent Blues, and in today's topic we are going to talk something related to deep sea. Now deep sea has generally intrigued scientists by the way the habitat exists and a lot of things that are quite berserk. For a background, there is a fish which is called Mariana snailfish, and as per the name you can guess that it is found very deep inside the ocean, and it's named after Mariana Trench, which is one of the deepest places in the ocean. It has a roughly depth of around 11,000 meters. So where this Mariana snailfish exists, there is a pressure of roughly 1.1 kilobar, which if I translate into something which is tangible, it is equivalent to one you can say school bus per square inch. That's how much pressure you have at that depth. The scientists were always intrigued that why this or how do these fishes survive, because if you talk about a human, for example, the bones would definitely crack at that pressure. And most importantly, if I talk about from a biochemical perspective, the proteins that exist in our body which carry out the different functions, they would denature. Basically they would lose out their structure at such a high pressure. Scientists found that as you go deeper down in the ocean, there is a particular chemical and the concentration of that chemical keeps on increasing, and that chemical is called TMAO, that is trimethylamine N oxide. So till now it was not really clear as to what TMAO would be doing, which is basically helping these fishes survive deeper down in the ocean. Very recently a study was published to actually try and find that what this TMAO is actually doing, and the results were quite interesting. So what they found was that when the pressure was really low, that means at close to atmospheric pressure, the water was behaving normally, that was, it was existing in this tetrahedral environment. But as soon as you increase the pressure or you go to high pressure situations, this water, the structure of water, the tetrahedral structure and the hydrogen bond network starts breaking down, and the tetrahedral structure basically distorts. But in presence of TMAO, what is happening is it's somehow stabilizing the water. So this TMAO basically interacts with the water in a way that even at high pressure it is able to stabilize its tetrahedral structure. Therefore the biochemical parameters and the proteins present in these fishes do not get denatured. Now if I talk clearly about the applications, well, there could be many, some even that we haven't conceived till now, but I see its applications in food chemistry, wherein when you are basically transporting food at high pressures, the proteins inside the food get denatured. So somehow if we can find a chemical which is biocompatible, which can be added as an additive to this food, so that when it is getting transported, the food does not get denatured or degraded, that could be one critical application. And if I talk about on a more sci-fi front, then maybe a chemical that mammals or humans could consume that would give them this superpower to go deep down inside the ocean for a few hours before its effects get weared off. Obviously we have a lot of bones, so we also need to find a way that our bones don't crack, or maybe we could come up with a robot or an unmanned vehicle which is made of cartilages and which is fused with this particular chemical which provides protection at very high pressures, which can go explode deep down inside the ocean. So this is something that I can think of at the top of my head. So anyway, I hope you found this video helpful. If you want to know more about the study, if you want to read it in a lot of detail, I'll give you the links down in the description box. Make sure you go ahead and read these studies. I hope you found this video helpful. If you did, please give this video a big thumbs up or like the video if you are watching it on Instagram. And if you like this particular way of presenting things, then do let me know. Whenever I have the time, I'll try and present it in this way, even though it's a little more time consuming, but I think it really drives the engagement forward. So thank you for watching. I'll see you in the next video very, very soon.